All right. So yeah, basically, we're gonna be doing like a sorting algorithm to find like the peak out element. So one of the ways to solve it is like, you could go through the array and actually have like ON complexity by just comparing each one to another. So, you could start like with the first element and then you could go on and compare them, but that isn't like the most optimal. Um, I want you to think like of a way of how we can optimize this with like one of the sorting algorithms that we have learned in class. And I'll give you a hint. It is like a log n type algorithm. So yeah, any step of the way, just let me know. And for the solution, you're going to be like returning the index array. So yeah, it'll be like 2 for this one. And if it's like another one, like let's say 3 and 2, it can the solution can also be like, let's say this would be 4.
Okay.
So you're only supposed to return 1, but as long as like it finds 1, you should be good. Do you have like any follow-up questions?
Um, okay, so there could be more than one heap. I mean, sorry, heap, more than one peak, in which case I
Yeah,
can just return either, the index of
yeah.
either. Um, are there any constraints on the length of the array? Like if, well, may I be given one that's length 0? Or,
Well, no. There's no like edge cases. Most of the arrays are gonna be yeah, greater than 1 or 2, or like I'm pretty
okay,
sure like you can't just have like a peak at 1. Like so most likely you'll have like an array of 3. But yeah,
okay.
don't worry about that. Let's just say like you're getting an element with like more than 3 um numbers, and yeah.
And there's definitely at least one peak.
Yeah.
Okay. Um, let me think. So I'm looking for something maybe, excuse me, of
Okay.
log n complexity, which is interesting because now I have to think of a way to find a peak without necessarily doing, looking at all of the elements. Um, okay, well, I know that I'm going to be probably implementing some sort of sorting algorithm. My guess is that, and I could be wrong, but my guess is that it's going to be some variation of a sorting algorithm because sorting the array doesn't really solve the problem, right?
Yeah.
Um, because because then you have no peaks. So I imagine it's going to be something like I'm going to be looking at the first element, for example. Okay, and I guess here's another question that I maybe can ask about sort of edge cases. What if, like, if I'm looking at the first element, could the first element maybe be a peak? Like, say, for example, if I change the second element in this example to 0, is this 1 now a peak or is it not a peak?
Um I guess you can consider it a peak. I really like the question on leak code isn't like really specific on like what is a peak or not. I just know like that their solution does work once like implemented, I guess.
Okay, so maybe
So
don't.
yeah, yeah.
So,
Um, what are some divide and conquer algorithms that you know that can solve like basically split this array
I
into like
see.
subcomponents
Like a
and
merge sort.
yeah,
Okay, so if I'm remembering merge sort, and I'm not going to do any code yet, maybe I'll just try and sort of visualize it if that's all right.
yeah, so good.
So I think merge sort you kind of split it into 2 to start. So here's splitting that array from the example in half. Um, and then I could go ahead and call the same method for each subarray. Um, and I want to do this until I, I
Right.
guess until there's 3, right? Because the
Yeah.
length of 3 is where I could find a
Uh,
peak.
Yeah. So I want to yeah. So you're kind of like a little bit ahead. I want to ask like what happens like how do you split that array? How do you know like to split that array? You know, you have um you wouldn't first need to know like the size of the array, right? So you know that like we're starting from an index of 0 to whatever size. And then we're splitting that through, let's say, by like adding them both together and then cutting them in half, which would give you a middle element, right?
Mhm.
With that middle element, now you're from 0 to the middle element, and then middle element plus 1 to the end of the array. Now,
Right. Yeah.
with that being said, how can you repurpose that middle element so that you're checking just the middle element?
So that I'm
Just to
checking.
like,
Sorry.
yeah, you're checking like the middle element to see if um to see if you know it is a peak or not. So I yeah, just think about how maybe you can
Okay. So
yeah
in this case, oh, sorry, I think you cut out. So in this case, there's 6 elements in the list, so I don't really have a single middle element, right?
yeah it would be um it would be 5 divided by 2, which would be 3, and then would it be minus 1? Yeah, and then yeah, so I think you'd have up to 0 to 2, and then 3 to 5. Um, what specific do you want to know about, like the middle element?
Well, I was just trying to. I think I might have been struggling to understand what you said about just looking at the middle element when I split it. Um,
Yeah. So in a case where the I guess like in a case where it's evenly split, the middle element can be either one, and
I
then
see.
you would just yeah, you would just have to like find a way to compare it to
I see. Okay.
and see like if it is a peak or not.
Yeah. Okay. So uh, I guess good practice might be to look at the left element, since say if we're
Mhm.
dividing, we're going to end up flooring the decimal. So
Yeah.
I would look at the 3, and then to check if it's a peak, I could look to the at the element to the left, assuming there is one, and also to the first element in the right array, and compare them to see if that element is a peak.
Yeah. Yeah, and that's kind of like the main like um the main strategy for that. You're getting the middle element, and you know for sure that well, you don't really know for sure that like this side will be less than, but you'll know that like as long as you can compare maybe like these three, you'll maybe find like a peak element, and if you don't, you just keep splitting it until like you get like to like you have this one, and then this one would be the peak element, and then you would just compare these the two
Right.
neighbors to the side. Yeah.
So my so I have a feeling this is going to have a recursive nature to it since I'm splitting. Um, my base case that I would be looking at would be when the array is of length 3. Does that sound correct? Because if it's length 3, then I can check to see if each element is a peak. The middle element.
Yeah, so yeah, you can have a base case up to 3, I guess. Or you could keep it as well as a while loop while as long as like the two indices that decide, like let's say this would be like the third index and the fifth index, as long as they don't cross each other, you know that well, you know that like you can't go past that. So
Okay.
yeah, I don't know
I
if that made sense.
That made sense, and I think I preferred the iterative solution over the recursive solution, so maybe I'll
Yeah.
go with that. If that's all right.
Yeah, sounds
Um,
good.
maybe I'll try to start coding then. Let's see. So as you mentioned, I'm going to have some left and right bounds. So I'm going to start with my left bound. All right, Google Docs is going to capitalize things, but so I'll leave it. But I'll call it left maybe. And this is just representing the index. So it's going to start at 0. And then the right will be array dot length, I think, parentheses, -1. So now we have left as the first element and right is the last element. And then I want to do this while left is less than right. In other words, while they haven't crossed over. If they have crossed over and I haven't come across a peak, then I think I can safely say that there is no peak.
Yeah.
So maybe if that's an edge case, I can deal with it later, but it's something to keep in mind. So at this point, I think I want to get the middle element between left and right to split the list in half.
Mhm.
So I'll just create another index and I'll call it middle. It just to represent the index, which will be the average. Right plus left divided by 2. Okay. So just trying to think here. I would like to get the subarray between. So like first it'll be between left and middle, and then second would be middle and right. So I'm just trying to think of if I need to actually create a new array to do that, or if I can just perform the operations without formally creating that array. I think maybe I don't need to. Let's try. So as you mentioned to me, I'm going to be looking at the rightmost element of the first array and also the leftmost element of the second array to see if they're peaks. So maybe I'll say something like, I'm trying to come up with a good variable name. Well, maybe I don't need a variable name. Maybe just go straight into an if and say if array sub, this will be this right element here in the left, the rightmost element in the left array.
Mhm.
So this will be 0, 1, 2. So it'll be, I think, middle, right? 0, 1, 2, or middle -1. Middle. If array submiddle is greater than array submiddle -1, and array submiddle is greater than array submiddle +1, then it's a peak. And I am assuming in this case that both of, array middle -1 and middle +1 exist. So I'll have to think about that next. But if that's the case, that's a peak and I can just return middle. And then otherwise, excuse me, to look at the rightmost element, to look at the leftmost element in the right array, if array submiddle +1 is greater than array submiddle array submiddle and array submiddle +1 is greater than array submiddle +2, then it's a peak. Return middle +1. Okay. This is not formatted the best. Let's something like think that's all of the brackets. Otherwise, if I haven't found a peak, then I'll say left plus plus and right minus minus. Oops, although this should be inside the while loop. Left plus plus, right minus minus. Yeah, so I think, although I probably don't want right minus minus, right? I want to split the array in half. So I would say,
Yeah, that's
I see.
so you can have maybe like a helper function, I guess, like if that would make it easier to like split those in half. And then uh um
Because there is going to be some recursive nature.
yeah, well, mostly, yeah, there is a bit. Let me just try to like figure out a way to say it. So yeah, you know how like the merge sort would call itself? You can basically just do that. Just like call the peak for, put the left and right array into these functions, and then it should return.
Okay.
Yeah.
So I could do a helper function, or maybe I could even, if I wanted to
Yeah.
get fancy, I could have default values. So like left is equal to 0. Oh, that might not work because I need to know the size of the array.
All right.
Okay, I'll create a helper.
Yeah.
So it would be int, I'll just call it peak helper. Int array,
Yeah.
int left, int right. Okay. Something like this.
Yeah. Yeah, it looks good so far.
Um, and then I would copy and paste this in here. Okay.
Yeah.
Okay. So in the main method, which will be called externally, I would want to call, let's say, return peak helper, where I'm giving it the array, and then 0 and array dot length, or -1, length -1. Okay.
Mm-hmm.
And that way, up here, I can, rather than doing, okay, so I think my while turns into an if, probably. I don't even know if I need that anymore.
I I yeah, I think so. Yeah, it doesn't really matter because like
That's true.
yeah.
And then rather than left plus plus and right minus minus, I'll say peak helper left middle, I believe.
Yeah.
And then same thing here. I feel like I'm missing something in here. It's probably middle plus 1, but take these out.
No, I think you probably solved it mostly. Like, yeah, the whole purpose of it was to, I guess, like, yeah, we could just go into like discussing the solution. Yeah, a helper function would have been like helpful at the beginning. Yeah, and I think like with this solution, yeah, you're splitting each array into halves, and then but before that, you're checking that middle element to see if the middle element is a peak, and depending, whether it goes left or right first, it's gonna return a peak based on like which one came first. So like you're checking here the the right or the left side of the array. So it'll probably return a peak for the first half first, and then if it doesn't find one there, it will return for the other half. Yeah. I just noticed. You can see my screen the whole time, right?
I could. I wasn't looking, but yeah, I could.
Yeah. I didn't notice that, and I forgot. But yeah, I was looking at it just because like I looked at it like a few like 2 days ago or something like that. But yeah, it's basically the same thing. Um, you have like that function, that like the helper
Okay.
function, and then yeah, you're basically you have them. Yeah, you got the middle, and then you're checking to see if those conditions are met. Else you find the peak for the right side, and then I think yeah, and then this would be like the peak for the left side. So it's like a different implementation, kind of like for this one. I don't know why it compares like if the mid is greater than 0 for some reason. I
Oh,
really don't. Yeah, I really don't know if like they were supposed to like be in order or something like that, or like why. But your solution kind of like works that way, where like you're getting that middle element, and yeah, you're comparing it to the other two neighbors. So yeah,
interesting.
and I guess like a follow-up question is like, what would be the space complexity of your implementation?
Yeah. Um, oh boy. Well, it, it it is a recursive, so I would say everything about how that works. I think it's probably also mm, is it n log n because you have to initially store the entire array, but then I think after that it's just log n. Is that
Um, I don't think you're using extra memory. Besides like the original array, I think you're not consuming extra space on top of like the original one. So I don't think it would be like, I think it's like, oh, I don't even know. I don't think it does have a space complexity. I think it's just like 0. But yeah, okay.
oh
I'm gonna
cool.
stop sharing. Yeah. Hopefully I was recording this whole time.